Hi family, friends, this is Mark Tandle. I'm watching a video here. It's about the electric universe as opposed to the gravity-driven universe of the mainstream astrophysics. This here is Wallace Thornhill. I think he's the most knowledgeable human being ever in the history of mankind as far as how the universe actually works. This video will also have David Talbot. He's an expert in ancient human mythologies, and Donald Scott. He's an electrical engineer, and between the three of them they created the Thunderbolts project team, and I became a member back in 2006, and their presentation of an electric universe is changing everything we think we know about how the universe functions. So I'm going to back this thing back up and start the volume, and you can watch for yourself. Donald Scott, Wallace Thornhill, and David Talbot and the Electric Universe.
Certainly Tony Peratt is at the top of that list as far as first-rate scientist that pointed Dave and I in new directions that we wouldn't have been familiar with otherwise, you know. And it turned out to be revolutionary in its implications. And so it's been, you know, we've been very fortunate from that standpoint to be associated with the community of scholars where everybody has complementary and supplementary ideas that can kind of serve as a self-corrective mechanism to keep us on the straight and narrow.
I could name a number of people who have been key to all of this, and one of them is Velikovsky's scientific advisor, Ralph Jurgens. And he published an article in the early 70s which challenged the view of how the sun works. And that was one article where, as I read it, I intuitively knew that he was right, because the model was simple. And it was based on engineering principles, which I understood. I felt I had to take that on board and then see what else could be done with it.
Dave met up with Wall, and Wall began to talk about electrical things and said that this configuration that Gruba says is stable is definitely stable. The electrical properties of these planets would be consistent, and we can go from there. We can have a model and see if it works. Then I got into the act a little bit later, and after I'd read Jurgens' electric sun model, and I was more interested in the sun, still am. There were other people who shared in the similar ideas with Dave, and Sev Cochran and Eduardo Cardona, Jimental, and a few other people. So the whole group sort of came together. The impetus was Dave and his study of ancient times and ancient stories. That's the way the whole thing got started, and then little by little we've sort of expanded.
This community of scientists and scholars eventually became known as the Electric Universe, or EU for short.
The electric universe acknowledges the fact that all matter is electrical in nature, and that we can understand far more about the universe, cosmology, and ourselves by using this understanding and applying it to a simplification of all of the present physics, which involves multiple forces and multiple particles, a complete zoo of particles, and a lot of confusion, especially with some of the very expensive experiments that have been carried out recently, which have produced just more surprises rather than confirmation of previous ideas. I'm so confident in the interdisciplinary support for the electric universe model. It's not so narrowly focused as modern science is. Most people are so focused on their own area of interest that they don't consider that the problems they're facing may be answered by somebody in a completely different discipline. The communication between disciplines is very poor at present.
That's Wallace Thornhill.
The EU has several aspects, a whole bunch of different directions. Dave with his mythology, and Eduardo, God love him, and Walls and my ideas about electricity and how it all can work. And there's several other aspects of it, too.
My name is Andrew Fitz, and my particular interest is in the sociological study of catastrophism. So everybody's different. That's what's exciting about this group, because there's room for everybody. I mean, you got the hardcore scientists, mathematicians, you got the mythologists, you got the psychologists, you got the geology people, you got people wanting to show you the proper understanding of what an atom is.
Wolf, and I became involved in the whole Velikovsky community. In 1974, there was a conference at the University of Lethbridge where Velikovsky was given an honorary doctorate, and I was invited to be one of the group to give a paper, and that's where I finally met Velikovsky, and we were then in touch for the rest of his life. He died, I think, in 1979. Velikovsky vigorously argued that abstract gravity is not the answer to the motions of the heavenly bodies. He believed that electromagnetism played a part, and probably in his mind the greatest part. So he was the one who pushed 70 years ago for electrical interactions in the universe, particularly in the solar system, and Dave Talbot and Wall have picked up from there, and they now say that the entire universe, the whole bloody universe, as big as we know it, is electromagnetic. And this is just starting to come out. What Wall and Dave have started is going to be a torrent of insights into how everything from the smallest parts of the cells in our body to the largest structures in the universe can all be only explained in terms of electricity and magnetism, or electromagnetism together. So they're on their way to proposing a whole new paradigm for understanding of reality.
100% correct. Everything is electromagnetic.
I'm Bill Mullen, and I teach classics at Bard College. I've done that since 1985. So I've been giving papers at conferences inspired by Immanuel Velikovsky, starting from the year in which I worked with him, 1973 to 4. You see the Great Canyon of Mars, a third of the planet. It is a canyon whose features could not possibly have been produced by erosion of wind or water, but who perfectly resemble the kind of configurations that electrical discharges produce. I mean, even in a laboratory. And it takes NASA photography of that Great Canyon, and you look down into the canyon and you see these incredibly sharply etched features all the way to the bottom. That is some mega discharge of some other body close enough to Mars to have produced a huge, as it were, lightning bolt.
The EU, our guys, are of the opinion that there is a heck of a lot more electricity up there in space than most astronomers think. The surface of the sun is very electrical. Thinking about it that way, we've been able to explain some things that regular astronomers, helioastronomers, have no explanation for. We think that stars are born from Birkeland currents. When the Birkeland current gets into a pinch, for whatever reason, you bend it like you bend a soda straw, you will crimp it, and any restriction or crimp, there'll be what's called a Z-pinch, and the plasma reacts and essentially explodes and compresses matter. And that's the way we feel stars and all objects, planets, asteroids, anything you want to think of, are made because of the compression of matter at a Z-pinch in one of these long current streams. The reason that I got into the electric universe was because of my background in electrical engineering. And when I heard astronomers say things that I knew were wrong, I am a reasonably expert, I think, after teaching it for 39 years in Maxwell's equations and a few of the other electromagnetic properties of matter. Astronomers are saying things like, there's an open-ended magnetic field here. An open-ended magnetic field. That's nonsense. There is no such thing. And they talk about magnetic fields that begin with a footprint on the surface of the sun and then they go to infinity. That's impossible. They may go a long way, but it's not infinity because electromagnetic fields have to come back and join. They're continuous closed loops, just like a circuit would be a continuous closed loop. Astronomers have some very wrong ideas about, well, you can't have charge separation in space. Yes, you can. You can't have an electric field that would push on something and make it to move in space. Yes, you can. So I kind of get into this by sort of like running out onto the field like a referee in a soccer match going, time, that's a penalty, you can't do that. And so astronomers have been saying for a long time, plasma cannot support an electric field. Plasma is a perfect conductor. It will short out like you put a dead short across the battery. It's going to melt everything and nothing's going to work. They're wrong.
My name is Peter Model. As I understand it, our whole foundation of the thrust of science is material, is materialistic. It's based on the research of physics, physical things. And more the idea came in that physics can answer everything, to the point where what isn't physics isn't real. Yeah? It went in that direction. The whole viewpoint, and this is implicitly behind it, where actually science can answer anything, and what they're not answering doesn't exist. Yes, in other words, a non-material existence and so forth doesn't have a place. Now, gravity is actually associated, in general understanding, with matter. The amount of matter is supposed to be the amount of gravity. And so, by having a universe that's based on gravity, you're actually supporting the whole idea, the whole material idea that lies behind this physical approach. When you shift to electricity, this whole thing drops out. And so the difficulty that many have in letting go the fact that gravity is a negligible force in the universe compared to electricity is because gravity is still tied in with matter. And if you have electricity, well, it's not matter. So there's a whole other range of understanding that has to move in and that has to let go this materialistic basis.
Gerald Pollack, and I'm a professor at the University of Washington in Seattle. And I've been, for the past couple of decades or so, I've been studying water. The electric universe people are generally of the belief system that electrical forces dominate nature, the solar system, and the galaxies and such. The feature of weather that we have brought forth is that weather is primarily electrical. And it's not a surprise because you see thunderstorms, electrical storms all the time. And for many people, the presumption is that the electricity is something added on or something exotic, but it's not. The clouds are all electrical. The rain, it turns out, may be drawn to the earth by electrical forces. Most of us think you have a cloud up there and the cloud somehow magically, for some reason, unzips and all the water comes out and falls down. But experiments have shown that it's not true. The droplet is not just falling from the cloud. Something is pulling the droplet down. And from our studies, we deduced that these are electrical forces because these droplets are all charged. And most people never even think about this. How come this heavy water is sitting above our heads and it doesn't fall, except when it rains? And so this is a kind of funny question that I always like to ask. And we think we know the answer, and the answer has to do with charge, just like the electric universe people are realizing. The cloud is negatively charged. And it turns out that the Earth is negatively charged as well. you have a negatively charged Earth and a negatively charged cloud repel each other. And if they repel each other, then the cloud is going to be high up, and the clouds that have more negative charge are going to be higher, and the clouds with less negative charge are going to be lower. When you listen to your local meteorologist talking about the weather forecast, you'll hear about temperature and you'll hear about pressure. Not once have I ever heard about charge. And I think answering the question, shall I take my umbrella to work today? We don't know, because often there's a 50% probability of rain. But I think that the predictions will get a whole lot better if people begin to understand that electrical phenomena dominate all weather.
Of course, to be able to really grasp and propose such revolutionary ideas, it is necessary to abandon some outdated but deeply held beliefs about the nature of the universe and its history.
It was about almost 40 years later when I suddenly realized that to get any further, I had to discard Einstein's way of looking at things. It was a necessary step. I had to take that step, to take the ones that were just to come, just down a few years later. I had to dump Einstein and go back to the classical way of doing science. I was working in London at the time, and there was a scientist who actually wrote the entry in the Encyclopedia Britannica for some years on special relativity, until he realized that he didn't understand what he was saying. And he developed a very simple argument which ended up in the Times. It was a famous argument in the London Times. It was never resolved. So he decided, since he never got a proper answer to a very simple question, to write a book called Science at the Crossroads. With that reinforcement, I was prepared for anyone who attacked me on the basis that, Einstein is the hallowed gentleman, and that no one can question him because everything that's ever been done confirms his work. Well, that's so, simply because he removed the standards of measurement of time and distance. So once you've done that, and you can choose any arbitrary observer in the universe to match, to give you the results you want, sure, The fact is that doesn't actually prove anything, because his work is fundamentally, physically meaningless.
I like to say Albert was no Einstein.
There are all sorts of other aspects to this, but one of the main things about the electric universe is that it re-establishes the standards of measurement. And that is, and this is something that Newton recognized, and some of the great philosophers of the past, the standard is the fixed stars, the rest of the universe. So it's motion with respect to the rest of the universe that determines the energy and the actual speed of an object.
If you look at Einstein's own work on general relativity, he has a couple of pages describing the assumptions or the principles that he uses, and then there's pages of mathematical equations. Now, most physicists would be trained to look at his math and then to train to look at the field equations and to kind of gloss over the assumptions part. But all of those assumptions are themselves up for debate or questionable. They're ways of framing the problem.
However, physicists are not trained to question the assumptions.
Well, this is the problem, the way it's taught. You imagine you go into school and everyone is chanting hymns to Einstein. You're going to be excommunicated, tossed out. You'll never have an academic career. It's quite a challenge because each era seems to work with its own mythology, and that sets the ground rules for what you believe and what you don't believe. And science is just another mythology. It's funny because science, of course, is supposed to have separated from religion. It never did. It even took the creation myth with it and added maths to it to suit whatever they wanted to dream up. And so we've ended up with scientism. It's really nothing to do with real science.
part of the problem is that the scientists have taught what was taught in 1950 since 1950 and before.
An example of someone who was thrown out of school for challenging Einstein's ideas is Stephen Crothers, who was a physics PhD candidate at the University of New South Wales.
I've done work on special theory of relativity, general relativity, and its related mathematical apparatus, thermal emission, that's including, of course, Kirchhoff's law and Planck's equation, which I've done with Professor Robitaille, who's been working on this for years, and is essentially the prime mover on this. So we've written one paper together on that, and I also do a bit of work on electrodynamics.
Kirchhoff's law of thermal emission is a pillar of modern physics. Assuming its validity, Max Planck went on to formulate his famous equation, which proposed that electromagnetic energy could be emitted only in quantized form. Quantum physics was then born.
Black holes, big bangs, these things don't exist. It's all a fantasy. The cosmic microwave background is essential to the Big Bang cosmology, but we know that they can't possibly exist because, first and foremost, all of this rests on the validity of Kirchhoff's law and the University of Planck's equation. But as Professor Robitaille has done recently with a very simple experiment proving that Kirchhoff's law is false. So this is a very simple experiment that anybody can do in their kitchen. I mean, literally in your kitchen, with a small amount of outlay for equipment, maybe $1,000. You don't need a $100 million satellite, or hundreds of millions, or $750 million satellite, like many of these, or these various satellites have cost. And of course, these projects, who can reproduce these so-called experiments? You have a one-off, more or less, or you have a small coterie of people who have controlled these projects, and they make ancillary projects to the project that they've done to confirm their own claims. Well, there's no independent inquiry here, or no independent confirmation, so it's not science.
I think there is a problem with peer-reviewed things, especially when the peer reviewers have an interest in the accepted theory. So they're going to be very careful about letting you publish anything that's contrary to their accepted theory.
Peer review doesn't work. It only works to protect the status quo, the settled science. Confirmatory bias is one of the big problems in science. In other words, forget your failures. In fact, half the time you don't even publish them. This is one of the other difficulties. So we have this skewed view of where science is really up to. And people who have relied on an expert in one field to give an answer which they can rely on is often misleading people in another discipline. And so you get these knock-on effects, and the results are that science at present is a real shambles. The real scientists are the ones, usually the first ones to admit it. The ones who are just there for the show will say anything to maintain their position. Oh, the quantum business, well, that's not science either. Physics died at the Solvay conference, you know, the one where Einstein and Bohr and all of those other big names of science were assembled. We had Einstein in the front row, they're all seated, of course. This is settled science, so they're all seated. He was the one who destroyed physics by removing the standards of length and time. And in the second row, second from the end, was Niels Bohr, who removed cause and effect from quantum mechanics, which meant that that was no longer physics. So we've limped along since that early part of the 20th century, not doing physics. The problem is we see all of these things that are put as facts and conclusions, which are not facts, and they are unsupportable.
Big Bang is based on the general theory of relativity, and Einstein's general theory of relativity is riddled with contradictions, impossible physics, so-called physics. It's a bit of an oxymoron to say physics, but impossible physics and invalid mathematics. There is two things that a physical theory must satisfy. It must be logically consistent, and it must be in accord with reality or experiment. Well, if it fails on either one, then it doesn't hold. And in the case of Einstein, certainly on the question of logic and self-consistency itself, it's false. So that doesn't hold. The second thing is it's been experimentally proved to be false because, as I said about Kirchhoff's law, without that law, the whole of Big Bang cosmology is untenable. Well, Kirchhoff's law is false. That's it. So we know for sure that this Big Bang mysticism, it's not science, and it's a fantasy.
The Big Bang is nonsense. It's been called the ultimate free lunch, because you start with nothing and you end up with everything. It's only there because of a misinterpretation of redshift. There's a lot of ironies in science too, because no one bothers to check the history or the documentation. You accept what you're taught, because in university it's a hothouse. You've got to get through and do what you're told to do in order to get your degree. You don't have time to go back and look at the controversies and the thoughts and the context at the time. Edwin Hubble thought that the expansion of the universe was the least likely answer, and he was right. Right to his deathbed, he thought that the Big Bang scenario was the wrong one. But of course, he's now up there, another icon, and history's being rewritten by the winners. And unless you go back and do your own checking, you would never know it. It's the same with most of the so-called big steps forward in science. The politics of science is such that Nobel Prizes are misattributed to people who didn't invent something or didn't discover something but later developed it. And because this person who discovered it wasn't a card-carrying member of the fraternity, so to speak, gets discarded, and the person who develops it gets all the prizes. And this has happened repeatedly.
The singularity of a black hole is supposedly composed of a finite mass which has zero volume, infinite density, and infinite space-time curvature. Well, in general relativity, there are no forces of gravity. There are forces, but gravity is not one of them, because it's space-time curvature. Well, infinite space-time curvature, therefore, equates to infinite gravity. But there is no such thing as a finite mass of zero volume, infinite density, and infinite gravity. There's no such thing exists. This is a fairy tale.
It's like in mathematics in high school, where you have the equation for Young's modulus and the stretching of a spring. It's like applying that formula endlessly until the spring's long and broken, but you're still using the formula. This is what has happened. And the introduction of infinity into physics and the renormalization that they use, and then that's nonsense. If you hit infinity, you're no longer dealing with numbers, and your mathematics is no longer mathematics. I mean, it's a waste of time.
Is science still focusing on theories that have long ago lost touch with the physical realities they were made to explain? Biologist and science historian Rupert Sheldrake spoke at an Electric Universe conference, outlining the 10 dogmas of institutional science that are still taboo to question, even though they can be easily disproved with the existing evidence.
There's a conflict in the heart of science between science as a method of inquiry about the testing of hypotheses, looking at the evidence, finding out what's really going on, open-minded, subject to correction, and so forth. The ideal of science, which many people think of as what science is what science ought to be, and I agree with that ideal. The reality, as many of us have encountered through bitter experience, is rather different. For many people, science has become a belief system, a worldview. This is sometimes called scientism, where people take the dogmas of science to be a kind of religious belief system or quasi-religious belief system. And it's this dogmatic belief system which I think is now constricting and holding science back in a very serious way. In almost every branch of science, we see the law of diminishing returns. More expensive research yields fewer and fewer really new results. And I think the reason for all that is this dogmatic belief system. If science can be set free from it, new experiments and new possibilities open up in every area. What I do in my book, Science Set Free, is take the 10 dogmas of institutional science, which are part of the scientific worldview, and turn these dogmas into questions, treat them not as beliefs or truths, but as hypotheses that can be tested against the evidence. I then look at them scientifically to see how well they stack up when you take into account the evidence. None of them do. In every case, new possibilities open up. Science would become regenerated when we undergo this process. Science itself, of course, people at the leading edge of research in many ways have moved beyond this belief system. Research scientists are not necessarily committed to this in every detail, but they're usually only at the frontier of one region. A physicist might be at the frontiers of cosmology and have gone beyond some of these dogmas of physics, but they wouldn't question the dogmas of psychology or biology. Those would remain more or less intact. So there are various people who question bits of it, but there's very little that's been done to question the whole thing. This is essentially the materialist worldview. And it became the dominant view of science in the 19th century. Science was, as it were, hijacked by materialist philosophy, and since then has been a wholly owned subsidiary of materialism. There's really no reason why science has to be materialist. It wasn't materialist before the 19th century. And I think we can go beyond that to a new, more inclusive, more organic, organismic paradigm for science. So what if the electrical patterns in the sun are an interface with the sun's mind? What if the sun thinks? Now, as soon as you raise that question, you realize this is an utterly taboo subject. You're not allowed to ask that question. It's matters unconscious. Since the 17th century, materialists have assumed, and dualists, had assumed that matter's unconscious. It's simply off limits. However, all traditional cultures have treated the sun as alive, and indeed the planets and the stars. Children, when they draw the sun, draw it with a smiley face. So this in itself is taken as evidence against the fact that the sun can be alive or conscious, because if children see it that way, it shows it's a primitive, childish way of looking at things. And the fact that people all over the world show it that way until science comes along, again proves it's primitive and superstitious. We've risen above it. I don't think we've risen above it at all. I think we've sunk below it to a level of dogmatism which simply closes off a whole area of questions for no reason other than the fact that a French philosopher in the 17th century chose to divide up the world in such a way that he defined matter as unconscious.
The movement into the Renaissance was the loss of meaning. Then you moved to Bode's law, which gave you a formula for the distances of the planets, and that was good. What you needed were formula, calculations, and so forth, and if it meant nothing, it didn't matter anymore. And after the Renaissance, we moved into a period where things didn't have to mean anything anymore. There was no cosmic vision behind it. They just had to match up and work out. That has many, many more implications than what I'm saying there, but I have the feeling that we reached a crisis in the contemporary period where the lack of meaning is problematical again.
Well, science would improve by going back to a more classical style of teaching, where the scientists in the past had a classical background. They learnt about ancient cultures and so on, as well as investigating electricity and magnetism and astronomy and so on. There was a sense back then that science was all about simplification, that you tried to find a more simple way of looking at things. But it seems that after the two wars in the 20th century that government funding became very important, that the command was to shut up and calculate. There's an awful lot of mathematical work involved, which is rather deductive rather than inductive. And the way of operating back in the classical era was induction. You performed an experiment, you saw strange things happen, and then you tried to think of where you might have seen that kind of pattern of behaviour somewhere else. Now it was a case of if the mathematics didn't agree with the results, then you'd just fiddle with the mathematics until it did agree. But that didn't teach you anything new.
Something happened in the Renaissance which isn't often fully described. Here you have this free being who's able to make choices, but what actually happened is that man lost his identity at that moment, and there's a whole other way of seeing what actually happened, which has to do with the loss of personal meaning and the loss of personal connection. It's terribly sad that young people who have this impulse where things are meaningful and the starry sky is amazing and you want to discover more, and it's all turned into this abstract language which doesn't make sense anymore. And it's happening in almost all professions and all areas. How many wonderful young people have I known that went into the medical profession because they wanted to help people, nursing or other. And they got into a hospital situation, and they're the dispensary of medications or of operations or something, and the caring that was the initial impulse doesn't find its place anymore. And we can say this of so many areas of learning which lead us out of the reason that we went into them, instead of developing and becoming something even more intense. And that's something that's very true of our whole epoch. And it shows that something's amiss, something's dreadfully amiss.
It's one of the legacies of the split between philosophy and science in the 20th century. Is a strand of thought is sometimes called logical empiricism or positivism, which really greatly influenced science into this rise of the professional school of science, is to believe that science has to be free of metaphysics, and that it's the ideal is to have a science that's pure without having to make any such grounding claims or any such framing devices. So in my view, this is a delusion. And it would be much better if we could speak openly about what the guiding assumptions or the premises for a theory are, and speaking about them openly instead of trying to hide them away.
Well, despite Einstein's speed limit on the transfer of information, we know for sure that that's untrue and that the universe is full. It's full of an ether. You must have a substrate for the universe from which the visible things that we see, the planets, the stars and everything, must be constructed. You cannot create matter from nothing. You know, there is no miraculous creation story for the electric universe. The big mysteries remain, but at least we can now begin to ask the right questions. But the essential thing is this connectedness, and it's a connectedness at all levels, and it helps you understand the difference between living creatures, how we are formed, how we're connected with everything around us, the environment and so on, and how we're also connected to a kind of consciousness of the universe.
And there's reason to find either an organic sense or an integral sense or some way of finding personal meaning and global meaning in what we're researching. And I think the electric universe does open that possibility, where things are connected, stars are connected, galaxies are connected. Time is not a question. There's timelessness across the universe where we're in communication, and also the perceiver and what's perceived comes into a whole new relationship. And we're moving back into an area where meaning is meaningful, something that was lost for many hundreds of years.
Electricity electricity is the
It's all one.
unconscious God.
We're a manifestation of something beyond ourselves. That's my view, having come to this far down that path. To get to where I am, you have to be prepared to stare into the abyss and still take the jump. And I've done that repeatedly, so that jump is one that's not so difficult. It's also very empowering because you don't get so attached to meaningless things, the meaningless things in life. The real meaning is your experience here, because we are the self-referential part of the universe. The universe learns through us. We manifest in order to understand and to allow that understanding to permeate the universe.
If the electric universe model can really help explain the universe more completely and accurately than our current understanding does, why is institutional science so reluctant to consider it?
So prior to the proposal of the existence of electrical particles, you might say, of the electron, protons, and that, people didn't study things that hadn't been invented yet. So there was no electrical engineering. There was no real electrical physics. Electricity was unknown prior to, let's say, the turn of the century, 1900. And so they never studied it. And astronomers, they're trying to tell us what happened far, far away and long, long ago. Well, as we all know, that's the way any fairy tale begins. So they can pretty much say anything they want, because there's no way in their particular science to test anything. Well, it's a question whether or not untestable hypotheses are science at all. And because they never had electricity, they explained everything that they possibly could by any other means. Thermodynamics, fluid dynamics, now there is magneto-hydrodynamics. Because they thought they could get away with ignoring electrical processes and came up with a bunch of hypothetical answers for how things work, that when other people came along and suggested that these causations, these mechanisms that they wanted to explain, were really better explained by electrical phenomena, they rejected it because they never had studied it. I mean, in my 39 years of teaching, I don't think I had any graduate students from the physics department at all.
Right now we have cosmologists or scientists, more generally speaking, are setting all the terms for how to approach and understand the universe, and they're also the ones who judge whether they think a theory has more merit or not. To some degree, the core of the model is taken as a matter of faith, and that if you are to question it, then you risk running afoul of a lot of things regarding, funding and career and so on. On the one hand, especially if you are a scientist. You can build a career now on challenging some of the upper blocks, so to speak. For example, dark matter. There is a real challenger to this particular part. I find very few scientists are willing to look at the more questionable assumptions underneath the core building blocks of how we got here in the first place. It is much more convenient to add things to the model and preserve the existing structure than it is to radically rethink it.
And now scientists are coming out of the closet, so to speak, and letting us know that we're in serious trouble. But of course, the media aren't interested. All they want is the success stories from science, and that's all that the scientific hierarchy wants, because they rely on government funding and confidence in what they have to say, or what the experts have to say. The funny thing is, this is just a local anecdote about Australia, we have a government which promised innovation, and of course they asked the universities to head up this innovation, but they're the last people to ask.